Alright, so Unit 5, guys. I just said recently that Unit 4, in my opinion, is the most difficult because it's so much so fast. Okay, so much so fast in a little bit of time. Unit 5 is easier. It's easier, a lot easier in my opinion than Unit 4. There's just more to remember. Okay, so a good analogy I would probably say, like, I don't know, factoring. Quadratic formula is easy. It just takes forever. There's a lot involved. But I could also factor completing the square. It's a little bit different, a little bit more difficult per se. But if I learn it, you know what I'm saying? So it's like that. It's easier, but there's more information. And it's the top 2 most represented questions that you will see on the AP exam. So about 20% of the AP exam comes from this unit alone. And there's many units. They're all there on the back of the board if you didn't ever realize that. But those blue numbers, units 1 through 8, those are all AB calculus. Units 9 and 10 are including BC calculus. And we're about to do Unit 5. And look how big Unit 5 is. There's a lot of information on Unit 5. It's, in my opinion, a lot to remember, most applicable, but it's easy. Here we go. First of all, let's talk about mins and maxes. This is the pre-cal version because you're only looking at f of x. Now I'll let you read that. It's not very difficult to understand where the max and mins occur on a pre-cal level because you're just looking at an f of x graph. Okay, but then if I switch it up and I'm changing it now to calculus interpretation, there are more things involved to determine whenever we're looking at relative max and mins as far as looking at the derivative. Okay, so we're going to look at that here in just a bit. I'm not going to necessarily read through all of that because it's just too much to read and you're probably not going to understand. I'd rather go to the questions and so that you can understand where this is all tying to immediately. Okay, so I'll let you read that on your own. Yes, they are in Google Classroom as far as PDF notes. So in the figure to the right, this is an interval between -2 all the way to 4. It is a closed interval that includes the endpoints like a domain. So there's an endpoint there, there's an endpoint there. F has an absolute, it's the maximum, the Ohio State, I'm sorry, the maximum at where? At, in this case, we could just say x is equal to 4. F has an absolute, the minimum, at -2. F has a relative. So relative means you're not the, you're a, it's a peak, it's a small little neighborhood graph to where you're just looking at locally. Like if I were to compare us to Frisco and say, you know, are we max, or is our AP program max to theirs? Well, the answer would be yes. But that's local. This is like a relative. But necessarily, are we the absolute max that exists over all calculus classes across the world? That's a different, well, yes. Still yes, that is a different question though, okay? So you tell me, F has a relative max where? At x equals 0. X has a relative min at x is equal to 2. Now, there's a different question. What if I said, what is the absolute max? It'd be 21. This is the value. This is where it occurs. So if I said, what is the absolute minimum, you would say -15. Where does it occur? At x equals -2. These are these small little subtle details. It's easy, but your attention to detail has to grow big time. You have to be very nitpicky about everything that you say. The word it is not allowed in this unit. The word it is not allowed in this unit. This is the only place it is allowed in this unit, okay? So, anyway, so let's keep going. I got 3 laughs. Bonus points. All right. I laughed at his dumb joke. All right, so definition of a critical point. Critical points. So when you guys did that, I'm trying to show you exactly where this is going immediately. When y'all did that project with pre-cal, where you maxed out the volume of those like popcorn boxes, you looked at graphs. You looked at f of x. There's a faster, more accurate, way more efficient way to find those answers by looking at f prime of x. Okay? Now, you have to know that f prime, you are only looking at the critical points, the important points. For instance, if I had an investment on Wall Street that looked like this, I don't have to look at every single point on that graph. Because theoretically, there's infinite points on this graph. How many important critical points from this graph do you see? 6. Maxes and mins are critical, and so are endpoints. Maxes, relative. Relative maxes and relative mins are critical because the derivative is 0. The endpoints are critical because can you differentiate an endpoint? No, you need the other one-sidedness, like that bird needing wings analogy that I gave you way long ago. Okay? All right, so if the derivative is 0, it's important. If the derivative is undefined, it's important. You with me? So all you have to do is derive a function. And if you get a fraction, which you will get a lot of fractions, to do the ones that are important horizontal-wise, just set the top equal to 0. To do the ones that are important as far as does not exist or undefined, just set the bottom equal to 0, and you will find those. So factor everything, set the tops equal to 0, set the bottoms equal to 0. Those are your important points. Critical. All right. Relative extrema only occur at critical points. So look at these 3 graphs. And we're going to look at maximum, minimum points. So what is the minimum is at what? Say again? X equals 0. The point is 0, 1. If this is a scale of 1. Where does the minimum occur? 0. What? X equals 0. What is the minimum? Y equals 1. Okay? The maximum occurs where? X equals 2. So the point is 2, 1, 2, 3, 4, 5. What is the maximum? Y equals 5. Where is the maximum? X equals 2. All those subtleties, important details. Okay, let's look at this next one. Did the minimum change? No. Same. Did the maximum change? Yes. The maximum is where? Okay. So the limit as x approaches 2 on this function, whatever it is, let's call it f of x, from the left. This is where the maximum would occur. Do we know what number that is? No, so we can't tell. We wouldn't answer that. I wanted to show you theoretically what it is, but we're not going to put one, because we'll put none. There is no maximum, because you will infinitely be approaching that x value that you're trying to approach that y value, but you'll never get there. Okay? Did it change here? It did. So this was the same reason, right? But you're going to put none. maximum now stays the same. Good? Okay. Alright, so what conditions are necessary to guarantee that there will be a maximum and a minimum? What conditions are necessary that there will guarantee that there will be a max and or a minimum? That's it. That's it. The function has to be continuous. So if the function is continuous, and I drew a graph that looked like this, y is equal to 4. Is that a continuous function? Yeah. It's continuous on whatever interval I drew. Does this function, let's say it's y equals 2. Does this function have a max? Yes. The maximum is 2. Does this function have a minimum? Yes. The minimum is 2. So the minimum can still be the maximum. Yes. Good.
Is there any way for that to happen not on a straight line?
Yeah, it could be just a regular line. You know what I mean? Or a curve, whatever it is. I just wanted to make sure that you understood that each function that you draw, no matter what, will have both a min and a max, but it could be the same number. Yeah.
If you have one of those,
As long as it's what?
it's
Continuous.
if you have one of those functions where it's a line, would you be able to say the x value that has that maximum minimum curve like
Nope.
where it is an interval?
Nope. You would not. Nice question. You would not be able to say. You would just say, what is the maximum? What is the min? You know what I mean? Just like you wouldn't be able to say, where are the critical points? If they're all 0, they're all critical. You know what I mean? Okay. Alright, so let's go to now. So extreme value theorem, guys. This is one thing that we are talking about today. We're talking about extreme value. You can write these down. We're talking about mean value. And then we're going to talk about candidates test. Those are the biggest 3 things. Please write them out if you need to. Mean value, extreme value, and then candidates test. And then critical points, but I mean, you know that now. 4 things. And yes, I got to catch up with my calendar. I will put that up on Google Classroom over the weekend as well. So guidelines for finding an extrema on a closed interval. That means with endpoints. Candidates test. To find the extrema on a continuous function f on a closed interval, we must do the following steps. First of all, f prime and the critical numbers of f are listed between the intervals, between the endpoints. So identify, find all critical points where f prime is 0 or f prime is undefined. Step 2, evaluate f at each of those values. So we're going to make a table. We're going to find where are all my critical points occurring. So when I set this equal to 0, okay, set the derivative equal to 0 and set the derivative equal to undefined, which means set the denominator equal to 0. All those points that I find where that exists, those are going to be my candidates. They're stepping up to the plate and say, hey, analyze me. I might be the max, I might be the min. But I'm in the contention of one of those 2. And then, when we evaluate f at each of these critical points, it will give me these values right here. Okay? So, the numbers that we got will give me the values on the graph. Now this is important, guys, what I'm about to say. Huge, huge, huge. I found these zeros and the undefineds from the f prime graph. What graph are we going to plug this into right here? F of x. F prime's critical points. Remember like that graph that I showed you and you said that there were 6 important points? Those are all listed here. These are those 6 important points from the graph. The relative max and mins and the endpoints. Let me see if I can... How many critical points do you see now? Still 4. Still 4. Because, what's the derivative of those guys? Undefined. Or does not exist, right? The derivative, it's an undefined. It's an undefined slope. What is the derivative of these guys? And I see what I'm saying now. What we were saying with Dylan, does not exist. Because functions are undefined, derivatives do not exist. Okay? Alright, so yes, we're going to plug in those numbers into the function that we're analyzing. So the derivatives will give me all the important points, but I'm not going to plug them into the derivative. I'm going to, because if I plugged them into the derivative, what would I get? 0 or undefined. I'm plugging in those values into the function above. You see what I'm saying? And then seeing which one's the max or the min from that list. Will this always be f of x? No. It could be f prime. And if it's f prime, what are these? F double prime. Okay? Alright. Here we go. Let's go ahead and start with our examples right now. So, candidates test is huge for today. I have a function here from 1 to 5. And we want to find the absolute max and mins of this. Now, it isn't stated, but what must we know about this before we actually do this? It's continuous. Is this function continuous? Yes or no? Yes. How could you tell by a quick glance? How could you tell that this was continuous? Not brackets, not brackets, because I could have something that looks like this with brackets. This is not continuous from -2 to 2. It's not over anything. It's not, well, I could put this over 3. It's still continuous. It's not over anything with an x. Because if there's an x in the denominator, it has a chance of being divided by what? 0. Which would make it non-continuous, right? Discontinuous. Undefined pieces. Yeah. Cool. So, here we go. We're going to say, we're going to use candidates test. So let's say f of x is continuous. Thus f prime of x is equal to what? So the math is easy. The math is easy this round. This unit, I think the math is easy. But the details surrounding the math, you have to be on point because it's so detailed and specific. So 6x minus 24. From what you've experienced with me, what do you think I would want you to do next? Factor, right? GCF. GCF. Pull out this 6 and set it equal to 0. 6 equals 0? Nothing there. Well, what's my critical point? 4. So my critical point was 4. I'm going to list it as one of the candidates, and I'm going to plug it into f of x. I got the critical points from the derivative, but I'm going to plug it in to the function to see what does it equal. Guys, we've been doing this a lot, if you haven't noticed. We will find an at moment, and we will put it in both f of x and f prime of x, just like we were doing with implicit differentiation. Okay? Do I have any more candidates in this column? Yes, I do. -1 and 5, because they are what? Endpoints. And endpoints are always going to be undefined slopes. or does not exist slopes. Okay? So let's plug in -1. Without a calculator, 3, -24, -1. Synthetic substitution for speed, copy, multiply, add. Multiply, add. So 26 is that answer right there. Okay? Synthetic substitution. The coefficients descending account for everything. Now we're going to try 4. So we copy, multiply, add. Okay. Multiply, add. So this is -49. Okay? So far so good? Last but not least, we will go with 3, -24, -1. We're going to now plug in 5. Copy, multiply, add. What's that? -9. So I get -45, so -46. Are we good? So the math is easy. Now let's go to all the things that you're about to mention per this, per that, because this justification is a lot this unit, okay? But you had a good intro to justification with particles in motion, for sure. And there's a lot of correlation to those concepts to what we're going to do now. All right. What you're going to do is, this is definitely needed. And then you'd mention per candidates test. Look for the pers and look for the becauses. If you don't have enough pers and becauses, put some more. Okay? So per candidates test, because f of x is continuous, the table is required work. The absolute max, it says find the absolute max and state where the value occurs. Okay? So what is the absolute max? 26. The absolute max equals 26. And it occurs where? At x equals -1.
You couldn't say at x equals, you'd have to say and it occurs.
Or you could say at. So all this, you could, instead of and it occurs, just like Matthew said, you could, where it says, where it's blue, you could just put at. Or go straight to this at symbol. I like that at symbol. Or write it out, however you want to do it, okay? So if you wanted to do it like just spelling at x is equal to 1, perfect. What's the absolute min? Absolute min equals -49. Let's do it the way Matthew was saying it, at x is equal to 4. Are we good?
That's it for the justification.
That's it for the justification. The candidates test is the easiest one. It's still a lot of work, but it's the easiest one because it's the least amount of because it's pers and all that other stuff. They get more involved. Yes?
So, just to kind of clarify, the candidates test is you find what x equals for the derivative, and you plug that in plus the endpoints, which is the brackets up there, and that's all that you plug in.
That's it. So the candidate test is looking for the absolute. That's huge. Not the relative. So the candidates test, like I was showing you on those graphs from before, would analyze this at moment, at, and at. That's all of these values. What they would be on a graph, y-wise, that's what these are located as showing. You see what I'm saying? But it's only looking at the absolute. It's not looking at relative. let's see. Let's do one more of these just real quick. Let's go to D. So you would say f of x is continuous I should have done this with the other one, no worries, on 0 to 2 pi per candidate's test and here we go. F prime of x is equal to anyone? Come on, don't forget your basic differentiation.
Cos squared x plus minus sin.
So this is the same as sine squared, right? So it'd be 2 sine x times cosine x. So 2 sine x cosine x plus what? Or minus sine of x. Okay? 3-letter word. Or 3-letter word. 3-letter acronym. What am I going to do? GCF. So GCF out a sign so that you don't accidentally divide half your answers. 2 cosine minus 1. We're looking for our critical points. We're looking for our candidates. Okay? So when is sine of x equal to 0? Okay, look. This. Remember this recently that we discovered as far as arc sine and arc tangents range were between negative pi over 2 and pi over 2? And then arc cosine was here and here. We're not doing that if they give us an interval. Okay? So we're looking specifically at 0 to 2 pi. So in this entire circle, when is the sine 0? 0, pi, and 2 pi. So right now, in our work, candidates always require tables. And T for table, if that helps. That looks like a T. Alright. 0, pi, and 2 pi. I'm leaving space. Okay? Let's do the next one. Now we're going to set 2 cosine of x minus 1 equal to 0, which if I do basic algebra 1 stuff, it's the same as 1/2. On this entire unit circle, this is why we have you memorize it so quickly in pre-calc, when is the cosine of an angle a positive? Well, that's quadrant 1 and 2, or sorry, 1 and 4. What would be the value? Pi over 3 and 7. No? Yes. Right here. Let me show you.
11.
Pi over 3 and this guy. So 1, 2, 3, 4, yeah, 5 pi over 3. So pi over 3 and 5 pi over 3. So let's come over here. Pi over 3, I don't have to list them in order, and 5 pi over 3. Now the endpoints were, I got to account for the endpoints, 0 and 2 pi. You understand? Okay. Now I just have to plug them into the original position function and figure out which one's bigger, which one's smaller. Okay? So the original position function, I'm going to rewrite it just as sine squared plus cosine of x. And now let's plug in 0 right here and here. What's the sine of 0? 0. Squared? 0. What's the cosine of 0? 1. What's the sine at pi? 0. Squared? 0. What's the cosine at pi? Negative 1. Gotta be this quick. 2 pi. What's the sine at 2 pi? 0. What's the cosine at 2 pi? 1, so you see it becomes repetitive. What is the pi over 3? What's the sine at pi over 3? Root 3 over 2. If I square it, 3 over 4. Plus the cosine at pi over 3. What's the cosine at pi over 3? 1/2, otherwise 2/4. So this would be 5/4. 5 pi over 3 is here. Same points, so 3, 2, 1, 3, 2, 1, all over 2, negative square at the top. If you didn't understand that, no worries. So I just need to make this a positive x. What is the sine at 5 pi over 3? Negative root 3 over 2. If I square it, I get 3/4. Okay? And then what is the cosine at 5 pi over 3? Still 1/2. So whenever I add 1/2, what do I get, guys? 5/4. Can I have two at values that share the same max, yes or no? Yes. So you would say the relative max equals, or not the relative, my bad. The absolute max equals 5/4 at x equals pi over 3 and x equals 5 pi over 3. Where does the absolute min occur? At pi. So you'll say the absolute min equals -1 at x is equal to pi. Be honest, on a scale from 1 to 10, what's the level of difficulty right now? Oh, 4 at max, if that, right? I'm thinking more like 3. Okay, if you say anything below that, that's good. Yes. The max is 5/4 occurring both here and here, and the min is -1 occurring at x equals pi. I can't hear you, okay. Oh, I was just plugging them in when we were, or plugging the 0 in to get that one value. Alright, so to close it off, let's look at mean value theorem and Rolle's theorem. These are the last two things, okay? They're still correlated with what we're looking at today. Mean value theorem says if a function is continuous on a closed interval, that means it's differentiable everywhere, and differentiable everywhere between the endpoints, then there is at least one number c between a and b such that something. Let me draw it so that you can understand it. And then you tell me what it feels and looks like, because we've done something like this before. So if a function is continuous and differentiable, so no cusps, don't lift up your pencil. Okay? On A to B, that means endpoint here, endpoint here. Continuous, check. Differentiable everywhere in between those endpoints, check, because there's no jump discontinuities, there's no vertical tangents, there are no cusps or asymptotes. Then there's going to be at least one number c in between A and B, where what? Where do you think I'm going with this? Say again?
That's like the middle of the height.
Okay, so the middle of the height. He's thinking y values right now, because when we did intermediate value theorem, we were thinking y values. But now I'm not thinking y values, I'm going to be thinking slopes. Not 0, that would be over here on Rolle's theorem, but where the slope is equal to that slope. This is a secant slope. This is y2 minus y1 over x2 minus x1 is the slope between 2 points. You with me? So, there's one right here, and there's one right here, where the slopes of these lines are parallel to the slope of the endpoints. So we could say that there's at least one C. Here's one. Well, it's a little bit more to the left. And here's the other. At least one number C in which such that, here we go, f prime at C is equal to f of B minus f of A over B minus A. And there's variations of this, guys. You could multiply both sides by B minus A if you wanted to, and write this. Let's say I multiplied both sides by B minus A. It's the same thing. I could even move something over as far as saying f of B is equal to, move the f of A all the way over here and add the rest of this stuff. Otherwise, what you know as y equals mx, mx plus b. Cool? So this is where the tangent, which is right here and here, is equal to the what? Secant. Look at this real quick. Let's pretend that this is a position graph. If I go up, I'm moving forward. If I go down, I'm moving backward. If I go back up, I'm moving forward again. Let's say that I was in a car doing this, and this shows my position as time goes on. What would this line represent? My average what? Velocity. This is my average velocity. So if this was 30 minutes of a time interval, this is my average velocity. My average time, I'm moving forward. That's why it's a positive slope. The magnitude of that number is the speed that I'm moving. What does this represent? The two instances where at that moment in time, right here and here, it was equal to my average. You see what I'm saying? We'll get more in depth with that a little bit more next time. So Rolle's theorem, guys, is exactly the same. The only difference is, here's a little visual. Someone tell me, what do you think the slope is to that? Approximate it. Give it a number. 2. 2. Slope is 2. You're right.
I said 2 and then I said 1.
So let's say 2/3.
300.
300. So 200 over 300. There we go.
Oh, yeah.
So the slope is like 2/3. Okay? Rolle's theorem, there's your visual. All it cares about is where the slope is what? 0. Because Rolle's theorem is looking at the critical points that exist. Like I started off notes by saying, these are important because they're equal to 0. The only thing that Rolle's theorem says, guys, with what I drew right now, could I use Rolle's theorem? No. Because the secant slope, oh, that's not a curve. The secant slope is not what? It's not 0. For you to use Rolle's theorem, yeah, you were close. Rolle's. So Rolle's theorem is the endpoints have to be the same y value. Because if they have the same y value, their y2 minus y1 over x2 minus x1 is going to be 0. So let's finalize this last piece. Then we're done. Still continuous. Still differentiable everywhere in between the endpoints. And here's the kicker right here. If the first endpoint is equal to the last endpoint as far as the y, as far as the y value, then there's at least one point where f prime of 0 will equal f of b minus f of a over b minus a. But what is f of b minus f of a? If they're the same y value, 0. So definitely you're just looking for when is the derivative 0. You could say here, 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 and here. I know it was a lot, but it's still hopefully at about a level 3 at max 4. A lot to memorize. Don't try to just memorize like this. Try to tie it with what we've learned for conceptual understanding. I guarantee you, this unit will determine the path that you're at for the rest of the year. Trajectory. I'm not even kidding. This unit will show how are you using all the math that you've learned thus far. And if you're a conceptual kind of person, usually conceptual people don't like to do all that much homework. They like to understand though and see the big picture. Here is where you can get some momentum. So, any questions before we end it? Yep.
Is the only point of Rolle's there just to skip this even calculation?
The only point of Rolle's theorem is Rolle's just like, I want to be important. When these are the same, the slope is 0, give me the credit. It's the same exact thing as mean value theorem. Yes. Just like McLaurin did the same thing with Taylor polynomial series. Stepped in, up, it's whenever the 0 is 0, you know what I mean? The, I forget, radius and convergence is centered at 0.
So for the proof, you can say that C or F of C or F prime of C is equal to 0. You don't have to say the same.
No, well, you got to show this. This is why I put an
But if
asterisk.
you show that, then you can just write F prime of C.
Cool. Nice job today, guys.